5.2 is on synthetic division, and synthetic division is a shortcut way to do polynomial division, but it's very limited. It's only good for polynomial division when you're dividing by like 1x minus a number or 1 times x plus a number. And if I don't have my division problem set up with the x minus some 1x minus some number or 1x plus some number in the denominator of my fraction, or equivalently after my division sign, synthetic division won't work, and I would have to do long division. I teach long division in intermediate algebra. I'm not that excited about reteaching it, and we don't need to really remember long division for this particular chapter or at all in our class. But on the screen right now is an example of reducing this fraction using long division. I get an answer of x plus 6 with a remainder of 12. Of course, I could write it as x plus 6 plus the remainder 12 over the x minus 1. That's not what we want to learn. We want to learn how to do this division, or equivalently this division, using the shortcut method called synthetic division. And super easy. Synthetic division is done by first taking the coefficients of what's either in the numerator of the fraction or what's to the left of the division sign. Doesn't matter how the division problem is set up, whether it's written as a fraction or it's written as a division problem with a division sign. I'll take the coefficients of the numerator, 1x squared, 5x, and 6, and put them inside an upside down division symbol. And then I'll take what's in the denominator of the fraction, has to be either 1x plus a number or 1 times x minus a number. I'm going to take that, change its sign, the number in the denominator, change its sign, and put it to the left of my division bar. And then it's a repetitive process. I take the first number that represents the leading coefficient and I bring it down below kind of this inverted division symbol. And then I'm going to multiply the number that I put outside the inverted division symbol by the number on the bottom row and put that product underneath the second number, the number that I haven't dealt with yet. I've already worked with the 1 under this inverted division bar. I haven't worked with the 5, so I put that product there. And now I'm going to add those two numbers together. 5 and 1 adds to 6. And I'm going to repeat the exact same process. I'll take the number that's outside the division bar, multiply it by the number that I haven't multiplied by under the division bar, inverted division bar, multiply and put it in the next spot, and then add again. Now that I've used every number, the 1, 5, and the 6, this is going to be my answer. And I start by looking at the exponent of what I divided into. In this case, it's an x squared. I'm going to start writing with an x to the first power, this bottom row, as a polynomial. The far right number is always my remainder. And then reading from left to right, I start with this as the coefficient of my first term. My first term is going to have an exponent 1 lower than the original, so that's going to be 1x to the first power. Since there's no sign between, there's an implied plus sign. And then after the first power term, I get a constant. And so this would come out to be 1x plus 6, remainder of 12, and I can rewrite that remainder as a fraction. I don't know how well that explanation was, but I don't want to spend gobs of time on it because I will do a bunch of synthetic divisions. We should get good at it pretty quickly because it's not hard. So each of the problems between 1 and 10 want me to do synthetic division. They give me a fraction or something that's written as a division problem. In part A, I'm supposed to do synthetic division. To do synthetic division, I write an upside down division bar, put the coefficients of the numerator kind of here, 5, 18, 7, and minus 6. And then the x plus 3 in the denominator, I'm going to change its sign, make it a minus 3. That's the start for my synthetic division. Then it's bring down, multiply, add the whole way. So the first number that I've written above this inverted division bar, I'm going to bring down. And now I'm going to multiply. Negative 3 times 5 is negative 15. I'm going to add, but because the numbers have opposite signs, the adding is really subtracting, and I get positive 3. And then I multiply negative 3 times positive 3, get a negative 9. Put it in the appropriate spot. Again, I'm adding, but the signs are opposite, so it really is subtracting, and I'm going to get a negative 2. And then negative 3 times negative 2 is positive 6. Here I get a remainder of 0. This far right is always my remainder. Now, how do I write my answer to what this is? I start with my first term and I give it an x with 1 degree lower than the exponent in the numerator. So that's going to be 5x squared. So this 5, I'm going to make a 5x squared. This 3, I'm going to make a 3x to the first power. The minus 2 is going to be my constant, and the remainder is going to be 0. I need a sign between every term, so this one, the minus sign is kind of there naturally. Here, I get a plus sign because there's no sign. So I claim that this fraction, 5x cubed plus 18x squared plus 7x minus 6 over x plus 3, it equals to 5x squared plus 3x minus 2, remainder of 0. I don't need to write the remainder of 0. And in the bigger picture, I really want my remainder to be 0. Because if the remainder is 0, I can completely factor this numerator. So let me show you how to factor this numerator. I claim that this numerator, because I did synthetic division and got a remainder of 0, I claim I know how it factors. It very specifically factors into 5x. It very specifically factors into the denominator times my answer. And I'll show you that it works. So my denominator was x plus 3. And the answer, since it had a remainder of 0, is how this is going to factor. This is a huge deal. Let me show you that this actually works. Let me check this factoring, and I might even improve on this factoring a little bit. To check this, to make sure this actually multiplies out what it needs to, I'm going to multiply the x in my first parentheses by each term in the right parentheses. X times 5x squared, x times 3x, and x times minus 2. I'll do the same with the 3 in the left parentheses. I'm going to multiply 3 times 5x squared, 3 times 3x, and 3 times minus 2. This multiplication comes out to 5x cubed. That multiplication comes out to 3x squared. I'll put a plus sign here. This multiplication is minus 2x. That's positive 15x squared, positive 9x, and minus 6. I forgot this sign is wrong here. That should be a minus. Now let me combine like terms. This 3x squared and that 15x squared give me 18x squared. This minus 2x and that, which should be a positive 9x, I forgot the x there, should be a positive 7x. And this minus 6 is a minus 6. That equals exactly the numerator. That's the big reason why we do synthetic division, is because it allows me to factor a polynomial that I wouldn't generally be able to factor. Of course, this, you should know how to factor that further. If I wanted to factor this completely, this would be considered partially factored. To completely factor this, I should factor, or attempt to factor, 5x squared plus 3x minus 2. And to factor that, I'd multiply the 5 and negative 2 and get negative 10. find two numbers that multiply to negative 10 and add to 3. So here, this is my section 1.4 Intermediate Algebra Part 1. You should watch this if you can't factor this. The numbers are going to be 5 and negative 2. And I'm going to rewrite this problem, so I'm not going to really explain the factoring. I'm going to assume that you know how to do the factoring, maybe incorrectly assuming. But I would rewrite this problem with 4 terms. This negative 2x plus 5x equals that 3x, and then factor by grouping. Pull out a common factor of an x. Pull out a common factor of a 1. If you can't factor this, watch my video, section 1.4, part 1, or visit me on Zoom or in my office, and I'll try to teach you how to factor this. So, synthetic division gives me a tool to partially factor a polynomial, and then my previous knowledge on factoring gives me the ability to completely factor. So first I did the division using synthetic division. Because I got a remainder of 0, the synthetic division is a tool that allows me to factor. If I don't get a remainder of 0, then you'd have to put this remainder over here in this weird factoring. It's not useful. But if you get a remainder of 0, then you can completely factor the polynomial, partially factor with synthetic division, completely factor with some additional knowledge. So I'll do 4. Start off, part A, do it synthetic division. How do I do synthetic division? I write my backwards division bar and put the coefficients, in this case 9, negative 18, negative 16, and positive 32. Change the sign of the, well, I guess it's divisors, the words. I'm not that good at division words. I don't use those. But I changed that sign. I'm going to bring down the 9 and then multiply and add the whole way. So 2 times 9 is 18. Add negative 18 plus 18 is 0. 2 times 0 is 0. Negative 16 plus 0 is negative 16. 2 times negative 16 is negative 32. And then those add to be 0. So this division, this 9x cubed minus 18x squared minus 16x plus 32 over x minus 2 equals 2. This 9 is going to get an x that has 1 degree lower than that x cubed, so it's going to be an x squared. This piece is going to be an x to the first power. It's going to be plus 0x to the first power. This is going to be minus 16 as a constant, remainder of 0. Because I have a remainder of 0, I know how to factor this numerator. So this is the end of part A, although I wrote the answer oddly. I probably should have just written 9x squared minus 16. I don't need to mention the remainder of 0 if the remainder is 0, and I didn't really need to include that 0x. But that's for answer for 4A. 4B wants me to factor 9x cubed minus 18x squared minus 16x plus 32. And because the synthetic division gave me a remainder of 0, if I take the denominator times the result of the synthetic division, that will equal the numerator. This is considered partially factored. I'm going to completely factor this by factoring that, and that's easy factoring. I square root the 9, I square root the 16, and get a 3 and a 4. Divide the exponent of the x by 2 and get an x to the first, and then get a one parentheses with a plus, another with a minus. 9x squared minus 16 factors into 3x plus 4 and 3x minus 4. So I've done everything. I did my division using synthetic division. The remainder was 0, so I used the answer to my synthetic division to partially factor the polynomial, and then my knowledge of factoring to completely factor the polynomial. There's a trick in some of these problems, and problem 6 has the trick. In order for synthetic division to work, you have to have a placeholder for every power of x, starting with the initial power down to the constant term. And in problem 6, the numerator was missing an x to the first power term. If I jumped in and did my synthetic division without reimagining the problem with a 0x, I'd probably get the wrong answer. So now it's set up for synthetic division. Take my coefficients of 5, -6, 0, and 8. Change the sign of the -4, bring down the 5, and then multiply and add the whole way. 4 times 5 is 20. -6 plus 20 is positive 14. 4 times 14 is 56. 0 plus 56 is 56. 4 times 56 I think is 224. Add those and I get a remainder of 32. 232. My answer to part A, if I don't write the original problem down, it's going to be 5. The exponent's going to be 2. I go down by one exponent. So 5x squared. Then my x to the first power term plus 14x. Then my constant term plus 56. And then my remainder. I usually just write my remainder with an R. If it bugs you seeing it written with an R, you can write the remainder as a fraction. Synthetic division, when you get a remainder, is really not used for much of anything other than when we get, I guess, in section 5.4 we'll use it, but we'll only use the part, not the remainder part. So both of those will be answers for part A, and for part B, doesn't apply. Does not. Synthetic division is only useful for factoring if you get a remainder of 0. I could say that this, I could, it wouldn't be wrong to say 5x cubed minus 6x squared plus 8 equals to x minus 4 times 5x squared plus 14x plus 56 plus 232 after the parentheses, but that's garbage. That's not factored in any useful form. So it's not useful, the factoring for synthetic division, because you'd have that 232 that's not part of the factoring, and then all of a sudden it's not really factored anymore. So 8 is written sideways. 8, I have to really think of it as x cubed plus 512 over x plus 8. And even better, I need to think of it as x cubed plus 0x squared plus 0x plus 512 over x plus 8. That's the best way to think of it. Make my backwards division bar, get a 1, 0, 0, and 512. Change the sign of that x plus 8 to a minus 8. Bring down the 1. Multiply 1 times negative 8 and give negative 8. Negative 8 times negative 8 is positive 64. 0 plus 64 is 64. Negative 8 times 64 is negative 512. Get a remainder of 0. So this division problem, this x cubed plus 512 divided by x plus 8, it equals to 1x to the second power, I'm just going to write x to the second, minus 8x, plus 64, remainder of 0. So I'm done with part A. Because I have a remainder of 0, I know that I can factor this x cubed plus 512. X cubed plus 512 is going to factor into that x plus 8 times that guy right there, x squared minus 8x plus 64. And this parentheses, in order for it to factor, I would need two numbers, double negative, multiply to 64, but add to negative 8. The factors of positive 64 that are double negative, negative 1 times negative 64 multiplies to positive 64. In order to factor this, for what it's worth, I'm looking for numbers that multiply to 64 and add to negative 8. This is why I chose double negatives. Double negatives will multiply to be a positive, and they give me a chance to get a negative. But all of these numbers, if you add them, -1 plus -64 is -65, -2 plus -32 is -34, -4 plus -16 is -20, -8 plus -8 is -16. That guy is prime. This is considered completely factored. More often than not, when I do synthetic division and get the factoring, the second parentheses, it's not guaranteed to factor. It usually doesn't factor. One more, and then we'll break on to a part 2. Let's just do 9. Let's do 9 together. So for 9, I have to think of this as x cubed plus 0x squared plus 0x minus 27 over x minus 3, and positive 3 outside the division bar, 1, 0, 0, and minus 27. Bring the 1 down, multiply, add, multiply, add, multiply, add. For an answer to part A, it's going to be 1x squared plus 3x plus 9, remainder of 0. I don't need to write my remainder of 0. And I really don't even need to write the original problem to the left of this. Because I have a remainder of 0, I know how to factor now x cubed minus 27. X cubed minus 27 is going to be that x minus 3 times the result of my synthetic division, x squared plus 3x plus 9. This is prime as well. My numbers, in order to factor this, would have to be double positive and multiply to 9 and add to 3, and there aren't any numbers that do that. So that's a good stopping point, even though we're at 22 minutes. The next part, we're going to need our calculator. We're going to do synthetic division, but we're going to have to create the number that goes there.